Hello. One of the most requested features for Argos Translate is to translate XML or HTML documents, which is what we're going to be working on in this video. So, translating documents with tags in them is a little harder than it might initially appear. So, for example, as we can see here, you could have a sentence that has one word with a tag around it in it, or a handful of words within the sentence. And the way Argos Translate works is it takes this whole sentence, normally, converts it to tokens, runs all of those tokens through the translation model, and then out come translated tokens on the other side. Since in human language, there's not necessarily a one-to-one mapping of every token or word in the input to every token or word in the output, the same is going to be true for our tags. Which means we have two basic options. One, we could just strip the tags and then run the sentence through normally, which obviously would have no problems. Or we could translate before the tag, in the tag, and after the tag. But in that case, we would lose all of our context. So this is something we've been looking into for a while. I was talking to Piero about this on GitHub, Yasmin and some other people on the OpenNMT forums, and we were looking at this paper here. And what we came across and thought made the most sense was to do essentially do what she's describing here. So you would replace the tags with some tag token, and then you would, so if we take this example here, this would be tag open tag close or something. And so you would have these in your training data, and then you'd be able to, this would get tokenized as one token, this would get tokenized as one token, and so the tags would flow through the sequence-to-sequence model, come out the other side, wrapping the tokens that represent the same meaning of the text that went in, while able to use all of the context for translation. So the first issue we ran into with this is that the Opus parallel corpus data that we use does not have very many tags in it. So initially I wrote some code to essentially find the tags that existed in it and then normalize them to some standard tag, so the language model only had to understand the existence of one type of tag, but there just wasn't that much. And so that's when we went to this tag injection, as described in this paper. So essentially, you would, in this example, you would take this input, and then, you would take this input, which is a piece of data that you have, and then you would take the translation you already know works. And you would translate every possible substring here and see if it matched a substring here. And so, for example, in this case, you would at some point end up translating this substring, and you would get buen, and then you would realize that this is representing the same location in the sentence, and then you would insert your tag here, here, and here, and here. And so this would allow you to generate data with tags in it that you could then use to train this sequence-to-sequence model, which you can then use to do the translation. So, so I ran this. This was very slow because, as we were saying, so this would first translate the character J, then J-O, then J-O-E, then J-O-E-Y, and so forth. And once it got to the end, then it would start at O, and then do O, O-E, O-E-Y. And then each translation requires using our pre-trained models and running inference on them. So I ran a VM for a month and was able to generate, like I say here, 3,000 lines of tag data, as you can see here. So I still think this is a workable strategy, but it has a couple of issues. One, this would require retraining all of the models, which is expensive, and they're working fine otherwise, and not something I'd like to do in the near future. Another factor is that my somewhat speculative prediction is that within a few years, there are going to be language models available that are powerful enough that you simply put entire documents in HTML or XML format into them, and then they'll just spit out a translated version on the other side. So the combination of these issues makes the lifetime use of using the sequence-to-sequence model and tag injection to do XML translation relatively short. So what I was thinking is that we would try doing tag injection at inference time, which would have the benefit of not requiring retraining the models and not having to deal as much with weird output from the sequence-to-sequence models, and then we can ship XML translation today, let people start using it, and then if in the future language models are much more powerful and there's an easier, more straightforward way to do it, we can just upgrade people in the background. So that's what we're going to be doing today. So okay. So I was thinking we would have some kind of interface to manipulate tags within Argos Translate, and then we can tie that to XML or HTML later. One wrinkle is the Python XML library is not secure. So you can either import the secure one, or maybe just do HTML. But first we just need to get it working at all. So, um, okay. So we should just test this some. Um, oh. Oh, you can have two things named text. Or children. There you go. Okay. So now we need to include the actual translations. So Okay, so what do we want to do first? Probably just find a way to actually translate some of these tags. Okay. So the general strategy is if a tag is a literal, we just translate it. If it has children and the text is longer than a sentence, we translate all of its children separately and then combine them. Okay, so okay. So text equals tag dot text. If length text is greater than so translate children separately. Children equals tag dot children. And translation separately. Equals turn self child translate tag self child for child and children. That seems good. And then, so this is assuming it's not a tag literal. How do you get the type in Python? Get class is instance. Built it. Nice. Okay. If is instance tag, if is instance tag literal, then oh wait, so this method should be returning, taking in a tag and returning a tag. So this should be a tag literal. We want to return tag literal self text equals self.underline translation dot translate tag dot text. Okay, so we're trying to recursively go through. For literals, we just translate them. If it's too long, we don't, and then we'll just recombine them as tags. And then the actual interesting one is where we want to do tag injection to, so this will be for sequences under length 200. Okay. So we've got the text already calculated, so we can translated text is okay. So what do we want to do? For each child, if it's a literal, we want to reconstruct the tag. And then if we miss, we have to decide if we want to remove the tag, or I think we we want the tags to always maintain their form, and then if we can't find a match for injection, we will just translate without context. Okay. Wait, isn't tag injection then just always going to be this, at best, the same as translating without context? Because you're only going to be able to inject when you're only going to be able to inject when your single word translation matches the broader one. Oh, but in that case, you could translate the broader one using the context within the tag. Okay, yeah. So that still seems reasonable. Okay. Okay, I think I need to kind of sketch this out. So we're going to translate the whole thing. So if this is our input, we're going to translate the whole thing and have this. And then we're going to translate the tag and have this from the tag. So we want to loop through the children, and if they're literal, translate them, and then if we can construct if the injection works. So if the injection works for all of the children, we will then use the injected version. Otherwise, which will allow us to get the context for the broader translation. Otherwise, we'll just fall back to translating each tag contents by itself. Okay, yeah, that makes sense. Okay. Which this is... That's what this is doing. Yeah. Okay. And the children should be able to change order. For children, a child in tag dot. Okay, for child and children, for child and children, we should translate each child. So translated child equals okay, we only want to be doing, so we're really only trying to do this for a case like this, where there is like one word, we want to translate the surrounding sentence, I mean maybe two tags. We want to translate the surrounding sentence using that context. So maybe we come back to it, but the children should all be literals. Right? I guess they could. Okay. Translated child equals underline so we just want to, because we're never going to change the child's translation. We just want to, if we're able to match all the children, use this new broad translation with some more context. Okay. Child translations. Child translations that append okay. And then if all of the child translations are okay, wait, so back to our example. So in this example, the child translations would be, this would be a tag literal, this would be a tag literal, and this would be a tag literal. And so, assuming good matched Blaine, then we'd want to use, oh, so we'd need all three to match. So this would need to match. Okay, wait, let's draw this in the form we're using. So this is tag literal Joey is a tag literal good tag literal dog. Okay. And so we want to, so we're going to translate the whole thing to this, and then we're hoping that all three of these would also get directly translated. Wait, this format even seems wrong. Oh, maybe we should just represent these as strings, and then, because otherwise we're losing the difference that that good is in a tag, whereas the other ones are not. Because we only want to match good. Okay, let's see how that looks. So then we would say that children can be either a string or a I tag. Children if okay. Child.text if it's not a string, else just the child. Okay. Type tag string return Okay. That seems to work. Is instance tag. Okay. So let's just say these are the ones to match that are actually in a tag. If type child does not equal string. Okay. I can simplify this. Okay. For translation in child translations, if translation does not find okay, wait, so we want to find, so in this example we're going to have this, and then we're going to try to find, once this is translated here, we want to find the index there, and then if this is the case, then we want to reconstruct these tags. Okay. Dot find child translation. No, wait. Find substring. Yeah, so we're looking in the translated text, which has the context dot find translation not equal -1. I also want to deal with else. Okay. So in this case, we should have we'll need to check that they don't overlap too. Okay. Injection indices. Okay. Injection and Okay. So then we'll have this whole translation, and we'll know where to inject this. And then if we fail to ever find one, we want to do this. No, we want to do this. Okay. But assuming we find them all, then we need to reconstruct them. These may be off. Oh, jeez. Okay. Okay. So now we'll have the injection indices. So one concern would be that if we had two that overlapped, let's just assume they don't overlap for now. Okay. And so then, assuming they don't overlap, we have this, and we know which index this one comes from. Which means we've found all of, like, matches for all of the tags. Okay. So in this case, we would then want to output Joey and we have essentially this index. Okay, so I think we probably want to order these. Because right now we have So we don't need to preserve strings. We only need to preserve these that are tag literals. We could even just say this is tag literal. So we have a list of so we should combine them in a tuple and then order them by indices in the output. Okay, let's change this as name. Injection tags equals class injection tag, and it has a it has text and index. Well, tag. Okay. Injection tag is underlying. Okay, so these are the ones we're going to try to inject. And then injection tags that append. Injection tag. Okay. Injection indices. How do you spell indices? Oh, yeah. Indices. Oh, there we go. Okay. So we don't actually need that, though. So for injection tag in injection tags, and then we're trying to find this, and then injection tag dot injection index equals injection index. Okay. Okay. So now we have essentially we have this one which is hopefully matched, or no, that we know has matched, and we have this one which we know is matched, and then we have its index, which we're just going to assume is not overlapping with any other indices. So now we should order them. So then help this sort. So injection tags dot sort in ascending order. X dot check x. Okay, so now we're sorting them by injection index, and then to return is going to be this list, and then I equals 0. Okay. So for true so we want to go through adding text from the translation and text from the translation and the tags. So maybe just loop through the tags since everything revolves around them. For tag in tags, if I is less than injection tag dot index, then to return plus equals, which the injection index is a index in the translated text. Text I through injection tag dot injection index, and then to return, we want to create a tag literal with injection tag dot text, and then I equals injection tag dot injection index plus length of injection tag dot text. Okay. And then did this happen again? What? Okay. And then if I is less than length, translated text, then to return I can't do this. Dot append. Okay, to return append dot append translated text I. Okay, and then return tag to return. Okay, so let's take a look at this. Okay, so translate tag. So this takes a tag and returns an I tag. Oh, it takes an I tag or a string and returns an I tag or a string. Okay. So we get the text, which would break if it's a string. Let's move this up. Okay, so strings are easy. Except we have to actually translate them. Okay. So, assuming it is a tag, get its text and children, translate that, and then we're only trying on shorter ones. Okay. If it's a literal, we don't need this, but a literal's obviously easy. And then if that doesn't work, we do the whole injection tag thing where we find all of the literals in the oh wait, so this also so we also only want to try tag injection if all of the we only want to do tag injection if all of the children are tag literals or strings. Wait, children can't even... Wait, can children be strings? Oh yeah, okay, so we're saying tags can handle strings as children. List of either I tags of tags and strings. Okay. Okay, yeah. So let's do this here. Only do tag injection if all children are tag literal or string. Or I think I can do like a count. count Python satisfy lambda list. Oh yeah, that's good. Or length. So this is if oh, so we're trying to count the none strings. Actually, I'm going to do the filter. Filter lambda x instance x tag children is greater than 0. Okay, so if all the text is over the sequence length, we could probably do this, since this translation is slow, after this. Okay, so starting back at the beginning, so we're taking an I tag or a string and returning likewise. If it's a string, then we just translate it. If it's, otherwise we get the text and children. We're only trying to translate short text, so we just translate the children separately if it's long. And then we see if any of the children are of type tag, and if they are, we also are going to translate them separately. Oh, that's what this was doing. Oh, no, this is, and then if it's a tag literal, we can just translate the tag literal. And so this last interesting case is where we have children that are all strings or tag literals. Okay. And then we find the tags we're trying to inject, which are the tag literals, not the strings. And we translate them. And then we find the injection index in the translated string. Okay. And if we can't successfully inject, then we fall back on translating them separately. We're skipping overlap for now. And then we're going to sort by the injection index. And then we're going to go through the injection tags with also an index of the translated string. And if the string's less, or if the index is less, we're going to add that, and then we're going to add the tags back. Injection tag text. Yep. And then increment I. And then add it in at the end. Okay, yeah, that seems generally reasonable. So let's try to run it. Okay, so let's do the example we've been doing this whole time. Okay. T equals tag. Joey is a tag literal. Good. Okay. And then we need to actually get a Spanish translation. Okay. Okay. That seems like a bug. Well, we can just delete it. Okay. There we go. Okay. Okay, and then tag translation equals tag translation s. Okay. And then this is our tag, and then print tag translation translate tag t. Okay. So join this one doesn't seem to belong. Child.text. Oh, this one is supposed to be here. Okay. Valid syntax 46. Oh yeah, it's Python. That. The space is off again. Tag to return. Oh. Oh, there's the issue. with no length. Okay. Sort takes no positional arguments. Oh, cool. Text. Oh, that doesn't get us very far. Children. Okay, so it is returning a we're losing the tag. Okay. So let's add some logging. See, are we even getting here? Okay. Interesting. Do I need to spell it out? This is pretty confusing.